Good morning, dear students. Today we will discuss bivariate analysis for measures of association. Till now we have discussed bivariate analysis in the in context of test of differences, right? We discussed how to apply t-test and how to go about ANOVA. When you feel like there is a difference between two categories of a variable, or there is a difference between two variables, then you generally go for t-test or ANOVA. But when you feel like that these two variables are associated with each other, with it's not about the difference between two variables. Now it is about the association among two variables. For example, waking up in the morning and uh, rising of sun in the morning, these two are actually somewhere correlated, but reason behind both of them might be different. It is not like they are related to each other in a way like they are affecting each other. No, it is happening by chance, but these two things happen all together, right? Most of the times. Or you can say your company is doing very good right now, and you, along with that, you can say you have got very good employees in the company as in right now. So these two things are happening together, but they might not are affecting each other. This is happening, this might be happening by chance. There are different tests after checking the association among them. Those are related to relationship among variables. That is another thing, but still we will be checking whether two variables are going along or not, right? That is basically measures of association, how much they are associated and in which way they are associated, whether they are impacting each other or not. We will be discussing that all. Let us see what measure of association is. A general term that refers to a number of bivariate statistical techniques used to measure the strength of a relationship between two variables. Basically, we'll be checking whether two variables are actually strengthening the association or not. When it comes to the nominal scale measurement, then measure of association would be either chi-square, pi coefficient, or contingency coefficient, right? In case of nominal scale, when we have taken the data with the help of nominal scale, just the categories. Then when it comes to ordinal scales, that means you have the ranking data, then either you will be going with chi-square or rank correlation for measure of association. But when you have interval or ratio scales data, for example, the actual data, for example, profit of the company, advertisement expenditure of the company, like that. These are all actual data, right? Or maybe scale having regular intervals, for example, Likert scale, that is on the basis of 5-point scale, and they have the exact differences among each other, like uh, 3 means neutral, 4 means agree, 5 means mostly agree, and the same way 2 means disagree, then 1 means strongly disagree, right? There's a pattern, or you can say there is the similar difference is there among the parameters, right? So this way you will be you can be justifying it as interval scale. So kind of real data, right? So for that you will be going for measure of association like correlation coefficient and bivariate regression. When it comes to relationship among variables, these two tools you can say are highly used. One is correlation analysis and another one is bivariate regression analysis. Correlation analysis is basically this, calculating the correlation coefficient, and bivariate regression, you can say bivariate regression or multiple regression is also one of the part of measure of association, but that comes under your multivariate analysis. Technique remains the same, right? Let us discuss correlation analysis now. How do we calculate correlation coefficient? A statistical measure of the covariation or association between two variables. That means either two variables are associated with each other or they are varying at a similar pace, right? So we will be calling them as correlated variables. For example, Are dollar sales associated with advertising dollar expenditures or not? So, is it like sales are associated with advertising expenditure basically? Yes, most of the times they are. The correlation coefficient for two variables x and y is generally calculated as r, and in the leg it's xy. Let us see how it is to be calculated. First of all, r can range between +1 to -1. +1 is for a perfect positive relationship, right? And if it is a -1, a perfect negative linear relationship is there among the variables. And if it indicates 0, that means no relationship is there among the variables. Whenever you are trying to check the association between two variables, first tool you will be applying is correlation. We have just mentioned two major tools to calculate measure of associations are correlation and regression, right? Even if you are going for regression analysis, you will have to first go for correlation analysis, then only you will be proceeding towards regression analysis. Correlation tells you whether these are associated or not. If the variables are not associated, if it shows 0 or very low value, either positive or negative, then you will not go for regression, because this means there is no association, that means there is no impact, so you will not be going for regression. But if the value is +1 or or -1, that means they are perfectly correlated. But generally we'll be finding values somewhere between 0 to 1, positive and negative. And as per the association, we just mention, we just generally say if the value is above 0.07, above 0.7, then that means the variables are highly correlated. If they are near 0.5, that means they are moderately correlated. And the value, if the value is less than 0.30, they are low correlation. There is very low correlation among the variables. So this is how we generally go about correlation. This is all about r. How would we take the value of r to generalize the result, or say to explain the results? Now let us see the formula for r. This is the basic formula to calculate simple correlation coefficient, which is rxy or ryx. See, whether you write rxy or ryx, it is the same, because you can have a look at the formula over here. Xi minus x bar into yi minus y bar divided by xi minus x bar whole square and summation of yi minus y bar whole square, the whole square root. That means x and y hold almost same values, right? Or say almost same importance in the formula. So it doesn't matter whether you write rxy or ryx, formula would remain the same. So x bar here is sample mean for the values of x, and y bar here is mean for the values of y, and yi is the current value, and same goes with xi is current value, right? Value for ith column, you can see, right? So this is the simplest formula. Correlation is very easy to find, right? Or there is an alternative formula as well, and that is sigma xy divided by the square root of sigma x square and sigma y square, right? And this sigma xy is basically the covariance of x and y. This is sigma x square is variance of x, and this is variance of y. Like you can see it here, this is basically the variance of x, this is basically the variance of y, and this is your covariance of x and y, right? The same way you will be applying the formula. Correlation patterns. Can you see any pattern here? This is your x-axis, this is y-axis. For example, you want to check the employee's behavior on x-axis, and on y-axis is the sales of a product, right? Is there any correlation? No, because you might have check those employees behavior who are working inside the company. And product selling is the job of either the sellers or say your salespersons hired in the company, right? So these two would not have any relation. The employees who are working in the mainstream inside the company, who have never met your customers, and this is the consumption of the product, right? So this is having no correlation. That means it would be having value below zero point 0.3, right? When there is no pattern, there is no correlation. You can see the straight line here. Straight line means some perfect positive or negative correlation. If the line is like this, when x-axis is increasing, y is also increasing. X is increasing, y is also increasing. That means high positive correlation, right? But when it is like when x is increasing, y is decreasing, right? X here is this, x is when x is increasing, y has decreased, right? So that means there is a negative correlation. With increase of x, y is decreasing, opposite relation, right? So that is perfect negative correlation, right? You would never find perfect negative and perfect positive correlation among two variables until and unless we are actually checking the correlation among within the variable itself. This is the way you will be calculating the equation. Like you'll just get values and you have to put in the values and you'll get the answers, right? One more way of calculating the this coefficient correlation is calculating the R square. This is basically coefficient of determination. R square basically is explained variance divided by total variance. Whenever we go with the tables of correlation calculated through any software, we have a look at the value of correlation, that how much variables are correlated. We check the value of significance, p value, and then we check the value of R square as well, whether it is explaining the variance or not, or how much it is explaining the variance. So these three values are important while checking the correlation. The correlation value, which is shown in here in the table. Let us see the value first. Like this. For example, you are checking correlation among three variables, variable 1, variable 2, variable 3, right? So this is how the table would be generated. Variable 1 is associated with variable 1, of course, because this is the variable correlation within the variable itself, right? And then variable 2 is associated with variable 1 with value 0.45, and the another value is 0.031. That means variable 1 is highly associated with variable 1. This is called perfect correlation, right? So that is why I was saying you would never find perfect correlation between two variables until and unless the variable is same, right? Variable 2 is moderately correlated with variable 1 here, and variable 3 is showing low correlation with variable 1, and variable 2 and variable 3 are not correlated because it is 0.10. You can say very less correlated, right? Very less correlation is there, and 1 is for perfect correlation. Like this you will be getting the tables. So basically we have got three values now to check. One is correlation table, that would be showing the value of correlation coefficient, and then value of p, significance value, p value, which shows that whether the analysis is significant or not. Then the value of R square. R square tells us how much variance it is explained by the whole analysis, the whole correlation table. Yes, this is very important. Correlation does not mean causation. It is not saying that variable 1 is affecting variable 2 or variable 2 is affecting variable 1. This is different. If high correlation is there, that means they are just correlated. For example, roosters crow and the rising of the sun. Rooster doesn't cause the sun to rise, right? Because you see, yes, this is a saying and it happens every morning, right? Roosters crow and the rising of the sun. Either rooster does not cause the sun to rise, and everyone is aware of that. But sometimes when it comes to business problems, we are not 100% aware of the relationships or the measures of association, right? So it is very important to know, whenever we feel like that these two variables are highly correlated, this is not because of any kind of causation. That might be possible and might not be possible. So we have to take that in consideration, that this might not be because of causation. You have to remember that. For example, teachers' salaries and consumption of liquor. This has no meaning with each other, right? Covariate because they are both influenced by a third variable. Sometimes there is a third variable which is causing the same thing. For example, roosters crow and the rising of the sun. These two things are happening because morning has come, right? There is some third variable which is affecting both of them. Yes, correlation matrix, the standard form of reporting correlation results. Like we have just seen the results like this. This is your correlation matrix. This is the most important, say, this is the most important table, you can say, in case of correlation analysis. This tells you how much variables are correlated with each other, and then it would tell you the p-value as well along with these things, and then you will be checking the r value to see that how much variance is explained by all the variables altogether. Let us have a look at Walkup's law of statistics. Law number one says that it is related to your correlation thing. When we say that correlation does not always happens due to causation, right? So everything correlates with everything. Yes, especially when the same individual defines the variables to be correlated, right? When we are choosing correlation, when we are choosing variables for a company or for an individual, that means they are somewhere related, right? You have to remember that they would be related. Maybe some variables are less related with each other, some are more related, but they would be related. Then second law is, it won't help very much to find a good correlation between the variable you are interested in and some other variable that you don't understand any better, right? If there are variables which you want to prove that there is a correlation between them, and there is a variable which you do not understand much, then it is, it is a kind of waste of exercise to do that if you do not understand the variable well. Law number 3 says that unless you can think of a logical reason why two variables should be connected as cause and effect, it does not help much to find a correlation between them. Until and unless you want to, you have some idea that these two are related and these two have cause and effect relationship, you should go for correlation. After correlation, we generally go for regression analysis. Sometimes it is like that, if you want to check one variable's impact on another variable, then you will be going for regression. But before regression, you always have to check correlation among the variables, so as to check whether they are even associated or not. If the variables are not associated, you will not go further to check regression, right? So a measure of linear association that investigates a straight line relationship. We have just discussed correlation with perfect negative and perfect positive correlation, right? If that is so, then you will be checking regression and you'll see how much they are related and how much they impact each other. It is generally useful in forecasting. For example, you have 10 years sales data and advertising data as well. And then on the basis of that, you can forecast next year's sale on the basis of advertisement expenditure, right? A measure of linear association that investigates a straight line relationship, that is y is equal to a plus bx, where y is the dependent variable and x is your independent variable. A and b are basically the constants which we will be estimating in the analysis. A here is y intercept. It is an intercepted segment of a line and the point at which a regression line intersects the y-axis. And slope here basically is b, which is connected with x, and the inclination of a regression line as compared to a baseline, that how much it is inclined, that is basically the scope, and rise over, for example, run. D notation for a change in. For example, like this, there are two lines, right? You can see this line is inclined almost up to 45 degree, and this is like inclined maybe 50 or 55 degree, right? So this is, and this is starting from here, that means there is a constant, and this is a starting from here, and this would be the constant, right? The constant and slope b value would be calculated with the help of previous data available for x and y. That's all. We will be discussing regression in detail in our next presentation. It was just an introduction of regression because we have just discussed correlation, so it was important here. Let us discuss some true false. Number one, price is frequently used as an independent variable in marketing research. Is it? Yes, whenever you do any marketing research, price is frequently used as an independent variable because we are trying to check whether price is affected by any variable up to what extent. That is why it is dependent variable. So true. Second is measure of association is a general term that refers to causality. Is it? Measure of association is a general term that refers to a number of bivariate statistical techniques used to measure the strength of a relationship between two variables. And causality is not always hypothesized or determined with the help of measure of association, right? So this is false. Third is covariance is the extent to which a change in one variable corresponds systematically to a change in another. Is it? Yes, covariance is basically checked to measure the change in one variable corresponds systematically to change in another one. Then fourth is if R is equal to minus 0.88, this indicates a weak relationship between the variables under study. Is it? When this R is more than 0.7, that means this indicates strong relationship. Whether it is positive or negative, it doesn't matter, right? So this represents strong relationship. That is why it is false. Fifth is the measure of association used in the textbook is the Pearson product moment correlation coefficient, and its symbol is R. Yes, we generally use R as the symbol, and it is Pearson product moment correlation coefficient. You should remember this name because sometimes question comes like this, like explain Pearson product moment correlation coefficient. Then you might get confused that you don't know anything like that. Sixth is a Spearman correlation is more appropriate for interval and ratio data than is the Pearson product moment correlation. Is it? Spearman correlation basically is for ordinal data. We will be discussing that in the next presentation, and Pearson is used for interval and ratio data. So this is false. The correlation coefficient R indicates the magnitude of the linear relationships, but not the direction of that relationship. Is it? Correlation coefficient indicates both the magnitude of the linear relationship and the direction of that relationship. So it is not like just one thing. It is indicating both the things. So this is again false. Eighth is correlation always means that a causal relationship exists between the two variables under study. We have already discussed correlation does not always mean a causal relationship, right? So this is false. Correlation means correlation only. It might be causal relationship, but correlation does not tell us that this is a causal relationship as well. For that, we have to further go with regression analysis and check whether there's a causal relationship or not. So it is false. Ninth is the square of the correlation coefficient indicates the part of the total variance of y that can be accounted for by x. Yes, true. 10th is, in a correlation matrix, the main diagonal contains correlations of 0. Is it the main diagonal actually consists of correlations of 1.00, because it is the correlation of a variable within it with itself, right? So it is always correlations of 1.00, basically 1. So it is false. Let us have a look at some self-assessment questions as well. Number 1, discuss the procedures for testing association for data that are nominal, that are ordinal, and that are interval ratio scales. Initial 3 slides are on the basis of this only. For nominal data, the statistical choices, cross tabulation with chi-square, or say goodness of fit test. Then for ordinal data, the statistical choices, Spearman rank test. Then for the interval and ratio data, statistical choices, either Pearson's correlation or simple regression. Second is compare and contrast correlation, covariance, and causation. What do you mean by correlation here? Correlation basically is telling you the relationship, association between two variables, whether they are associated or not. That's it, right? Covariance would be giving you the covariance between two variables. Basically, contaminant variation is one condition needed to establish a causal relationship between two variables. When two variables co-vary, they display again concomitant variation. This systematic covariation does not in and of itself establish causality. The relationship would also need to non-spurious, and that any hypothesized cause would have to occur between any subsequent effect, right? So correlation is just telling you that yes, these variables are associated with each other. Covariance would help you in calculating the correlation, and causation tells you that these variables are affecting each other, right? That would lead you to regression. So these are these three things have very thin line between them. Explain how regression differs from correlation. Regression basically is a technique for measuring a linear relationship, linear association between a dependent and an independent variable. Although simple regression and correlation are mathematically equivalent in most respects, regression is a dependent technique, whereas correlation is interdependence technique, because it is actually telling you whether these variables are interconnected or not. A dependence technique draws a distinction between dependent and independent variable. That is dependence. We are checking one variable's dependence on the other. And an interdependence technique does not make this distinction and simply is concerned with how the variables are related to each other, whether they are positively correlated with each other or negatively, or they have no relationship. That is your correlation. Done? Thank you. In our next presentation, we'll be discussing regression analysis. We have just started with regression. I have just told you what regression is. We will be using regression in different terms in our analysis. So we'll be discussing regression in the next presentation.